Hello everyone, myself Manish Arya. I am a physics teacher for the past 9 years. Under my able guidance, many students have gone to IITs, NITs, and other engineering colleges. Well, I love teaching just for a single reason. It gives me immense satisfaction when my students are able to solve problems on their own based on what I teach them. I passed out from NIT Jamshedpur. My stream was computer science. Also, I got two on campus placement in software companies, but I did not opt for software job. Rather, I wanted to become teacher. Here again, just for a single reason. As a student, I was in love with physics deeply. I used to contemplate over physics problems, especially new one, a lot. Whenever I was able to solve problems on my own, I was, getting a lot of happiness and satisfaction. So I thought of sharing my knowledge, which I have acquired over the years. That's why I wanted to become teacher. Now, let's talk about my teaching style. So, given any complex concept, I tend to break it down into simple concepts, demonstrating those concepts with lots of examples so that students are able to connect those concepts with new problems. So that's how I teach them. In this way, students feel pretty much confident in solving new problems based on what I teach. Fine. Now, let's start with a topic that is conservation of momentum. This is a really an interesting principle in mechanics, and also many problems in mechanics are solved using conservation of momentum principle. So, let's understand it. The statement of conservation of momentum states that if net external force acting on the system is zero, then momentum of the system remains conserved or remains constant. So let's understand it here. Let's consider three particles of masses m1, m2, m3, and assume that m1 is moving with velocity v1, m2 with velocity v2, and mass m3 is moving with velocity v3 in any arbitrary direction. So if net external force acting on this system F net external is equal to 0, if this is the case, then momentum of the system, which is equal to momentum of all the particles m1 v1 plus m2 v2, momentum of the second particle, plus momentum of the third particle m3 v3, is constant. So this is the statement of conservation of momentum. So why it is happening? Let's understand it and prove it out. Fine. So from center of mass concept, we know that F net external is equal to mass times the acceleration of center of mass. Here m is the mass of the system, is m1 plus m2 plus m3 in this case. So this is from the center of mass. Now if net external force is zero, for we have the system, and the system consists of these three particles, and no external force is acting, or net external force on the system is zero, so we can say that if this is zero, then acceleration of center of mass is going to be zero. So if ACM is zero, then what does it imply? If ACM is zero, acceleration of center of mass is zero, then we can say that acceleration, which is the rate of change of velocity, is going to be either zero, and this velocity is of the center of mass is either 0 or velocity of the center of mass is going to remain constant, because differentiation of both of them will be 0. So what does first case mean? First case means that if center of mass is at rest and no net external force is acting on the system, then center of mass will continue to be at rest. This forms the Newton's first law for center of mass. And case number 2 indicates that if net external force is 0 and center of mass is moving with some velocity, it will keep on moving with that velocity in terms of direction and magnitude, so that its velocity is going to remain constant. Now, the second case forms the basis of conservation of momentum principle. How? We know that velocity of center of mass can be written in relation with velocities of individual particles as VCM vector is equal to m1 v1 plus m2 v2 plus m3 v3 vector over total mass of the system, which is m1 plus m2 plus m3. And now if VCM is constant from the second case, then we can surely say that m1 v1 plus m2 v2 plus m3 v3 is going to remain constant, because constant times the mass of the system will be constant. So here we say that m1 v1, which is momentum of the first particle, plus m2 v2, which is momentum of the second particle, plus m3 v3, which is momentum of the third particle, is equal to constant. And this is the proof of conservation of momentum for a system. Here, for the sake of simplicity, I have assumed only three particles. It can be extended to n number of particles also. So this is the proof. Fine. Now let us apply this conservation of momentum principle in solving one of the simple problems. So here, this is a cart. This problem consists of a cart which rests on a smooth surface so that mu is equal to 0, and a man is standing on one of the edges of the cart. Mass of the man is small m and mass of the cart is capital M. Now, man jumps off the cart with velocity Vr with respect to cart in final state. Final state because initially cart is at rest. When man jumps off, then it will exert force on the cart and cart will move in backward direction. So with respect to that moving cart, velocity of the man is Vr. Now the question asks us to find out velocity of the cart when man jumps off. So let's find it out using momentum conservation. How? Well, if we consider these two as a system, cart plus man as a system, then initially this system is at rest because man is standing there. And also we see that this is frictionless surface, so no external force is acting in x direction, in horizontal direction. So we can surely say that momentum of these two systems consisting of man plus cart, this is our system. For this system, momentum is going to be constant. So what is the initial momentum? The initial momentum is 0. because cart as well as man is at rest. And what is the final momentum? So for this, let's assume that cart is moving in backward direction when man leaves the cart, because man will exert an impulsive force in horizontal direction, due to which cart will acquire a velocity v in backward direction, and I am assuming v to be the velocity of the cart after man jumps off. So the momentum of this cart can be written as m into v, but v is negative in this case because our positive direction is towards right. So this is the momentum of the cart. And what is the momentum of the man? Well, momentum of the man will be what? What is the first of all, what is the velocity of the man with respect to ground? So velocity of the man with respect to ground will be Vr minus V, because Vr is velocity of the man with respect to this moving cart in this state. So with respect to ground, it will be the vector sum of Vr and V. Since Vr and V are in opposite direction, it will be Vr minus V in positive direction. So momentum of the man is m times Vr minus V. And when we solve this equation for V, we will be getting V is equal to m Vr over m plus m. So this is the velocity of the cart just after man jumps off. That's it. I hope you really enjoyed my lecture. Thank you very much.